Let us go for the next numerical on Vanta factor. Calculate the freezing point of aqueous solution containing 10.50 grams of magnesium bromide in 200 grams of water. Given molar mass of magnesium bromide is equal to 184 unified mass and Kf of water is equal to 1.86 Kelvin kg per mole. Children, remember magnesium bromide is an electrolyte which undergo dissociation. That means Vanta factor play an important role in the determination of delta Tf. Let me solve this numerical. Let me find out I first. Look at here, children. They say magnesium bromide, is it not? When dissolved in water, it undergo dissociation to give Mg2 plus 2 Br minus ions. Remember, for every 1 mole of magnesium bromide, you are going to get 1 mole of Mg2 plus and 2 moles of Br minus ion. Together 3 moles. Is it not? That means every 1 mole of magnesium bromide undergo dissociation to give how many? 3 moles of magnesium 2 plus ion and bromide ion together. Now I is equal to what? I is equal to total number of particles after dissociation. How many? 3 upon number of particles before dissociation, that is equal to 1. That means I is equal to 3 for magnesium bromide. Hope you are getting that. Now let me write the data given here. Given data, I'll write I first. I is equal to how much? 3. Now 10.5 grams of magnesium bromide, that means what? That means Wb is given. Wb is equal to 10.50 grams. Children, Wa is also given. How much? 200 grams. What else is given? Kf of water is given. Kf is equal to 1.86 Kelvin kg per mole. Then molar mass of magnesium bromide is given, that is equal to 184 unified mass. Is it not? Remember, one clue is given. You are dissolving magnesium bromide in water. That means water is a solvent here. That means you know this Tf naught of water. How much? That is equal to 273 Kelvin. Tell me why? Freezing point of water is equal to 0 degrees Celsius or 273 Kelvin. You take only one, either Kelvin or degrees Celsius. Hope you are getting that, right? Now, you know the expression. What is that? Delta Tf is equal to I into Wb into 1000 upon Mb into Wa. Is it not? Hope you are getting that, right? Now I is equal to how much here? 3. Wb is how much here? Wb is equal to 10.50 grams into 1000 upon Mb is how much here? Mb is equal to 184 and Wa, you know this, how much? 200 grams. Children, if you simplify this, you are going to get 1.59. Delta Tf is equal to 1.59. You take it as degree Celsius or Kelvin, doesn't matter, but keep it in your brain. If you take Kelvin here, you have to take it as Kelvin only. If you take it degree Celsius, you should take it as degree Celsius only. Are you getting or not? Now, you know the expression delta Tf is equal to Tf naught minus Tf. Hope you are getting that. What are they asking? They are asking freezing point of solution, Tf. Now Tf is equal to Tf naught minus delta Tf. Tf naught is how much here? 273. They are getting or not? 273 minus 1.59. Children, if you subtract that, you are going to get 271.41 Kelvin. This is equal to Tf. You can calculate in terms of degree Celsius also. If that is the case, I'll take here 0 minus 1.59, and then what are you going to get? Minus 1.59 degrees Celsius. Hope you're getting that, right? Children, let me take up the fifth numerical on Van der factor. Calculate the boiling point of solution prepared by adding 15 gram of sodium chloride to 250 grams of water. Given Kb for water is equal to 0.512 Kelvin kg per mole. Molar mass of sodium chloride is equal to 58.5 unified mass. Children, the non-volatile solute is given here undergo dissociation because sodium chloride is an electrolyte. So that is why Van der factor play an important role in the calculation. Now let me go for the solution. So given data, look at here, I is equal to how much? 2, because sodium chloride dissociates to form 2 moles of Na plus and Cl minus ion together. Now what else is given here? Wb is given. Wb is equal to 15 grams. Then what else? Wa is equal to how much? Wa is equal to 250 grams. Then Kb is given. Kb is equal to 0.512 Kelvin kg per mole. Mb is given. Mb is equal to 58.5 unified mass. Remember, the solvent is water. That means you know Tb naught is equal to 273 plus 100 degrees Celsius together 373 Kelvin. That means boiling point of water is 100 degrees Celsius. You are converting that into Kelvin, 373 Kelvin. Or you can keep it as it is 100 degrees Celsius also. Not a problem for me. Okay. Next, what are they asking? They are asking Tb, boiling point of solution. Children, let me put the expression delta Tb is equal to I into Kb into Wb into 1000. Is it not? Upon Mb into Wa. How is how much here? 2. Kb is how much here? Kb is equal to 0.512 into W is how much here? Wb is equal to 15 grams into 1000 upon Mb is how much here? 58.5. W is 250. Children, if you simplify this, you are going to get 1.05 Kelvin. This is delta Tb. Can put in terms of degree Celsius also, if you take here as degree Celsius. Now delta Tb is equal to, you know the expression, Tb minus Tb naught. Now what do you want? Tb, is it not? Tb is equal to delta Tb plus Tb naught. What is delta Tb? Delta Tb is equal to 1.05, is it not? Kelvin. Plus Tb naught is how much? 373 Kelvin. Why? You are taken in terms of Kelvin. Hope you are getting that. So together 374.05 Kelvin. This is Tb. So boiling point of solution, when you add 15 grams of NaCl into 250 grams of water, is 374.05 Kelvin. Children, let me give 2 numerical for homework on Van der factor. Very simple, you can easily solve them. Calculate the boiling point of solution when 2 grams of sodium sulfate with molecular mass 142 unified mass was dissolved in 50 grams of water, assuming Na2SO4 undergoes complete dissociation. Kb value is given here 0.52 Kelvin kg per mole. Look at here. For this, you should know whether this salt undergo dissociation or not. Children, sodium sulfate is an electrolyte. That means it undergo dissociation. Look at here. Let me find out I for you. Na2SO4, when it is added in water, look at here, it forms 2 Na plus SO4 2 minus. With every 1 mole of Na2SO4, you are going to get 2 moles of Na plus and 1 mole of sulfate ion. That means with 1 mole of sodium sulfate, which on dissociation gives you 3 moles of Na plus and SO4 2 minus ions together. That means I is equal to how much here? I is equal to 3. Look at in this. Calculate boiling point of solution when 4 grams of magnesium sulfate with molar mass 120 U was dissolved in 100 grams of water. Assuming magnesium sulfate undergo complete dissociation, given Kb of water is equal to 0.52 Kelvin kg per mole. Let me find out I for you. Look at here, magnesium sulfate undergo dissociation in water, is it not? In water undergo dissociation to form Mg2 plus SO4 2 minus. That means with 1 mole of magnesium sulfate, you are going to get 1 mole of magnesium ion and 1 mole of sulfate ion together 2 moles. That is equal to now I. Hope you are getting this. So after this you can easily solve both the numericals and solve them and tell me the answer tomorrow. Children, let me take up the next numerical on Van 't Hoff factor. A solution containing 0.5 grams of KCl dissolved in 100 grams of water freezes at minus 0.24 degrees Celsius. Calculate the percentage of ionization of the salt. Given Kf of water is equal to 1.8 Kelvin kg per mole. What are they asking? To find out the percentage of ionization, which is nothing but percentage of dissociation alpha. Children, remember, in order to find out the percentage of dissociation, we should know Van 't Hoff factor. That means first you should calculate Van 't Hoff factor and then you should go for the percentage of dissociation. For doing so, children, we should know normal molar mass and observed molar mass. Anyhow, normal molar mass can be calculated by using the formula KCl, where atomic mass of K is equal to 39, Cl is equal to 35.5. What is the observed mass? Children, that you need to calculate by taking the data which is given in the numerical. Let me solve this numerical for you. Solution. WB is given, is it not? How much? 0.5 gram of KCl dissolved in 100 grams of water, that is WA is equal to 100 grams. It freezes at 0.24 degrees Celsius. That means a TF is given, freezing point of solution is given. TF is equal to minus 0.24 degree Celsius. Children, one clue is given. What the clue here? Solvent is water. You know that freezing point of pure water, that is equal to TF or not. I'll take it as 0 degree Celsius because it is given here degree Celsius. Next, you should calculate delta TF. How do I do that? Children, TF or not minus TF, that you give the delta TF. Look at here, 0 minus of 0.24 degrees Celsius, that is equal to plus 0.24 degree Celsius, that would be delta TF. Children, Kf is given, is it not? Kf of water is equal to 1.8 Kelvin kg per mole. And what are you supposed to find out? You are supposed to find out observed molar mass by using the data given in the numerical. Now you know the formula, delta TF is equal to Kf into WB into 1000 upon MB into WA. So this is what you are supposed to find out. MB is equal to Kf into WB into 1000 upon delta TF into WA. Let me substitute the value. Now Kf is equal to how much here? 1.8. WB is how much here? 0.5 grams into 1000 upon delta TF. You found out here. How much it is? 0.24 into WA is equal to how much? 100 grams. Children, if you solve this, you are going to get 37.5 gram per mole or unified mass. This is what molar mass, that you should take it as observed molar mass. Observed molar mass. Children, once you found out the observed molar mass, now you need to find out normal molar mass. How do I find out? Look at here. Normal molar mass of KCl. How do I get that? Atomic masses of all the atoms of the element. If you add them, you are going to get the molar mass. In this case, formula unit mass. Look at here. K is equal to how much? Atomic mass is 35.5. That is equal to 74.5 unified mass. Children, look at here. You got observed molar mass. Now you found out normal molar mass. Now I need to go for what is that? Van 't Hoff factor. Children, Van 't Hoff factor, you know the relationship with the normal molar mass and observed molar mass. Van 't Hoff factor is equal to normal molar mass upon observed molar mass. Hope you are getting. Children, what is the normal molar mass here? It is 74.5. What is the observed molar mass? Here 37.5. 37.5. If you simplify that, you are going to get 1.98. I is equal to 1.98. Hope you got it. Children, now at the end we are supposed to go for degree of dissociation or ionization. Let me go for degree of dissociation. What the formula? You know that alpha is equal to I minus 1 upon m minus 1. Is it not? Now what the I value here? I is equal to 1.98 minus 1. Children, what is m here? Number of particles into each particle dissociate. That means in this case, look at here, KCl when added in water, it dissociates into K plus and Cl minus. Look at here, one particle dissociate to give two particles. That means m is equal to 2. I repeat again, m is nothing but number of particles into each particle dissociate. KCl dissociates into two particles, so m is equal to 2. That means 2 minus 1, that is equal to 0.98. Alpha is equal to 0.98. If you want to put in terms of percentage of dissociation is equal to 98%. Children, this is for 3 marks, very important for the examination. Children, let us go for the next numerical under Van 't Hoff factor. 1.5 grams of barium nitrate dissolved in 100 grams of water shows a depression in a freezing point equal to 0.28 degree Celsius. What is the percentage of dissociation of the salt? Given molar mass of barium nitrate is equal to 261 unified mass and Kf of water is equal to 1.86 Kelvin kg per mole. Remember, whatever the molar mass given here, it is a normal molar mass, but you are supposed to find out observed molar mass, then Van 't Hoff factor. After then only you have to find out degree of a dissociation of barium nitrate in the water. Hope you understand that. Let me take up the numerical. Solution. Given data. WB is given how much it is? 1.5 grams of barium nitrate. So WA is given, it is 100 grams. Children, they are given directly depression in a freezing point, that is delta TF, that is equal to 0.28 degrees Celsius. KF is given, is it not? How much? 1.86 Kelvin kg per mole. What else is given here? Molar mass, that means normal molar mass is given. Normal molar mass, that is equal to 261 unified mass. What are they asking? They are asking percentage of dissociation, otherwise called ionization. Children, let me go for finding observed molar mass, and delta TF is equal to KF into WB into 1000 upon WA into MB. MB you are supposed to find out KF into WB into 1000 upon delta TF into WA. Substitute the value. KF is equal to 1.86, WB is equal to 1.5, 1000 upon delta TF is equal to how much here? 0.28, and WA is equal to 100 grams. Children, if you simplify this, you are going to get 99.69 gram per mole or unified mass. This is what? MB. This I will take it as what? Observed molar mass. Observed molar mass. Now you got normal molar mass, you got observed molar mass, then you are going to find out Vanta factor. You know the expression? I is equal to normal molar mass upon observed molar mass. What is the normal molar mass here? It is equal to 261 U. 261 U upon observed molar mass, it is 99.69. Children, if you solve this, you are going to get 2.61. That means I is equal to 2.61. Children, once you got this I, now I need to go for calculation of a degree of dissociation, otherwise called ionization. Now I'll go for degree of dissociation. Degree of dissociation, you know, alpha dissociation is equal to I minus 1 upon M minus 1. What is M here? M is nothing but number of particles into each particle dissociate in water. Now let me take up, look at here, BaNO3 twice, barium nitrate. It is added in water, it dissociates to form Ba2 plus 2NO3 minus ions. Look at here, if you take 1 mole of barium nitrate, then it dissociates to form 1 mole of Ba2 plus ion and 2 moles of NO3 minus ion. That means each particle dissociates to form how many particles? 3 particles. That means M is equal to 3. Hope you got it. Now I substitute the value here. I is equal to how much here? 2.61 minus 1 upon 3 minus 1, that is equal to, look at here, 1.61 upon 2. Children, if you simplify that, you are going to get 0.805. This is alpha dissociation. Now if you want to put that in percentage, you have to multiply by 100, then you are going to get, look at here, percentage of dissociation is equal to 80%. Children, let me take up the next numerical under Vanta factor. 2 grams of benzoic acid dissolved in 25 grams of benzene shows a depression in freezing point equal to 1.62 Kelvin. What is the percentage of association given Kf of benzene is equal to 4.9 Kelvin kg per mole? Normal molar mass of benzoic acid also given, that is equal to 122 unified mass. Very simple, children. As you are done in the last case, you have to solve the numerical. Let me solve the numerical for you. Solution. Given data, children, WB is given how much? It is 2 grams of benzoic acid. WA is also given how much? It is 25 grams of benzene. And what else is given? Delta TF is given, depression in freezing point, that is equal to 1.62 Kelvin. Kf of benzene is given how much? It is 4.9 Kelvin kg per mole, is it not? And what else is given? Normal molar mass of benzoic acid, that is equal to how much? 122 unified mass. Children, what are they asking? They are asking percentage of association. I said in order to solve the percentage of association, you need to have, what is that? Observed molar mass. Once you find out the observed molar mass, and later you have to go for Van 't Hoff factor. After getting the Van 't Hoff factor, then only you can proceed for finding out percentage of association of benzoic acid in benzene. Look at here, we have delta TF is equal to Kf into WB into 1000 upon MB into WA, is it not? Now observed molar mass you are supposed to find out, Kf into WB into 1000 upon delta TF into WA. Hope you are getting. Now please look at here, Kf is equal to how much here? 4.9. WB is how much here? 2 gram into 1000 upon delta TF is equal to 1.62 into WA is equal to 25 gram. Children, if you simplify that, you are going to get 241.9. 241.9. So children, this is what MB, you can call it as observed molar mass. Hope you got it. Children, once you find out this observed molar mass, you know normal molar mass. Now you have to find out Van 't Hoff factor. Now I is equal to, you know that, normal molar mass upon observed molar mass. So normal molar mass is equal to how much here? It is 122 upon how much? It is 241.9. Is it not? Children, if you simplify that, you are going to get 0.504. This is equal to I. And while discussing about Van 't Hoff factor, I said that if the I value is less than 1, that means it is association. Because here I is equal to 0.504, that is association of benzoic acid. Children, once you find the value of I, now I need to go for what? I need to go for finding out degree of association. So degree of association, that is alpha association is equal to I minus 1 upon 1 by m minus 1. Children, I value, you know that how much it is? 0.504 minus 1. But m, what is m here? M is nothing but number of particles which associate to form single entity. Children, in the case of benzoic acid undergo dimerization. That means two particles unite together or associate together to form one particles. That means m is equal to 2. M is equal to 2. That means two particles associate to form one entity, a single entity. So 1 by 2 minus 1. Children, if I simplify that, you are going to get 0.504 496 upon 0.5 minus. So then you are going to get 0.992. So this is what alpha association. Now remember, if I want to put that in case of percentage, how do I put? Percentage is equal to 99.2%. Hope you understand that. Let me take up the similar type of numerical which has been given in the board examination. Children, let me take up the last numerical under Van 't Hoff factor involving association. The freezing point of a solution containing 0.2 grams of acetic acid in 20 grams of benzene is lowered by 0.45 degrees Celsius. Calculate the degree of association of acetic acid. Given Kf of benzene is equal to 5.12 Kelvin kg per mole. Children, again it's a very simple numerical and which is similar to that of the last numerical you solved for benzoic acid. So let me write down the given data. Wb is given, is it not? How much? It is 0.2 grams. Wa is given, it is 20 grams. And delta Tf is given, that is equal to 0.45 degrees Celsius. Then what? Kf is given, that is equal to 5.12 Kelvin kg per mole. Is it not? And you should find out normal molar mass of acetic acid Ca3COOH. That will be 60 unified mass. How are you going to get this molar mass? You add the atomic mass of all the atoms present in the molecule, then you are going to get the molar mass of that particular compound. Then what you are supposed to find out? You are supposed to find out, that is alpha association. In order to find alpha association, you need to find out observed molar mass. Observed molar mass and also I. So let me take up, this delta Tf is equal to Kf into Wb into 1000 upon Mb into Wa. Now observed molar mass you have to find out. Mb is equal to Kf into Wb into 1000 upon delta Tf into Wa. Now Kf is equal to 5.12. Wb is equal to how much here? 0.2 into 1000 upon delta Tf is how much here? Delta Tf is equal to 0.45 degrees Celsius. Wa is equal to how much here? It is equal to 20 grams. Once you substitute all the value, children, you are going to get the value for Mb, that is 113.7 unified mass. So this is what? Observed molar mass. Now normal molar mass. You also know about observed molar mass. Then I'll go for calculation of I. What is that? Normal molar mass upon observed molar mass. Now normal molar mass, children, how much? It is 60. Observed molar mass, how much here? 113.7. If you simplify that, children, you are going to get 0.52. I is equal to 0.52. That means it is less than 1. What does that mean? That it means that it undergo association. You learned that if I value is greater than 1, then it is dissociation. If I value is less than 1, that means it is association. Children, once you get the value of I, now I go for degree of association, and the relationship degree of association is alpha is equal to I minus 1 upon 1 by m minus 1. We need to find out the value of m, is it not? What is m here? Number of particles which unite or associate to form single entity. Children, in this case, acetic acid undergo dimerization in benzene. That means two acetic acid molecules combine together to form one entity. That means m is equal to 2. So let me put the value here. I is equal to 0.52 minus 1 upon 1 by 2 minus 1. Now if you simplify that, minus 0.48 upon minus 0.5. So if you simplify that, you are going to get 0.96. This is alpha association. Now if I want to put that in terms of a percentage, that will be is equal to 96%. So alpha association in percent is equal to 96%. Let me go for the next numerical. A 10% solution by mass of sucrose in water has a freezing point of 269.5 Kelvin. Calculate the freezing point of 10% glucose in water if the freezing point of pure water is at 273 Kelvin. Given molar mass of sucrose is equal to 342 unified mass and molar mass of glucose is equal to 180 unified mass. Children, let me solve this numerical. First, we need to find out molality of a sucrose solution. Right here, molality of sucrose solution. Children, you know the formula. M is equal to WB into 1000 upon MB into WA. That is WB into 1000 upon MB into WA. Look at here. For sucrose, WB is equal to, we say 10%. That means 10 grams in 100 ml solution or 90 grams of water. That means WA is equal to 90 grams. And MB is given. How much? MB is equal to 342 U. Children, I'll substitute the value 10 into 1000 upon MB is equal to 342 into 90. If we simplify that, you are going to get 0.325 molality. Children, once we find out this, let us go for delta TF of sucrose solution. Delta TF of sucrose. You know, delta TF is equal to TF naught minus TF. I know TF naught is how much? For the water, it is freezing point of pure water, that is equal to 273 Kelvin, is it not? It is equal to 273 minus TF is how much here? 269.5. 269.5. Is it not? Are they getting or not? Now, if you subtract that, you are going to get delta TF is equal to 4 Kelvin. And you know this, delta TF is equal to Kf into M. This expression you already learnt. Is it not? Now, what do I do? Kf is equal to delta TF upon M. Now, delta TF is equal to 4. M, molality is how much here? You have calculated 0.325. Children, if you simplify this, you are going to get 12.30 Kf, Kelvin kg per mole. You got the Kf value? Now, let me go for the molality of glucose. Molality of glucose solution. So, M is equal to WB into 1000 upon MB into WA. Look at here, WB, again 10% they say here, right? That means WB is equal to 10 grams and WA is equal to 90 grams because 10% solution. Is it not? MB is know that. MB is given here, it is 180 U. Now, W is equal to 10 into 1000 upon MB is equal to 180 into W is equal to 90. Hope you are getting that. Children, If you simplify this, you are going to get 0.617. 0.617. Children, once you get this molality of a glucose, now I'll go for finding out delta TF. Now delta TF is equal to KF into M. Now KF is how much here? KF is equal to 12.3. Molality is equal to 0.617. If you simplify that, you are going to get a 7.59. Otherwise, I'll take it as 7.6. So this is your delta TF. Now, by using this, you can find out freezing point of solution. Look at here, delta TF is equal to TF naught minus TF, or TF is equal to TF naught minus delta TF. TF naught, you know that how much? It is 273 Kelvin. What the delta TF value is equal to? 7.6. Hope you're getting that. If you simplify this, you are going to get 265.5. 265.55 Kelvin. So this is what TF. That means the freezing point of the solution is 265.55 Kelvin. Let me take up the next numerical. 30 grams of urea with molar mass is equal to 60 unified mass is dissolved in 846 grams of water. Calculate the vapor pressure of water for this solution if the vapor pressure of pure water at 298 Kelvin is 23.8 mm mercury. Children, it's very simple numerical. I have solved one kind of numerical like this earlier also. Even then I'll solve this. Solution. Let me write the given data. Children, in this case, look at here, WB is equal to 30 grams of urea. WA is equal to how much? WA is equal to 846 grams. And then MB is equal to how much here? 60 unified mass. And MA is nothing but for water, that you can calculate. Atomic mass of hydrogen is 1 and oxygen is equal to 16. There are 2 atoms of hydrogen and 1 atom of oxygen in case of water, together 18 unified mass. Is it not? So MA is over. Now what else is given here? Vapor pressure of the pure water, that is PA naught, is given, that is equal to 23.8 mm mercury. Mercury. Children, what are they asking? They are asking about PA. That means vapor pressure of water in that solution. Is it not? Now, you know the expression. You know what is that? Look at here. PA is equal to PA naught into GA. What is this expression? Raoult's law. Is it not? Now, let me go for GA. Children, GA is equal to NA upon NA plus NB. Now, I need to find out NA as well as NB. So, look at here. NA is equal to given mass upon molar mass. A is for solvent, is it not? Look at here. 846 upon 18. 846 upon 18. Is it not? Hope you are getting. So that is equal to 47. Right? Now NB, WB upon EMB. What is WB here? WB is equal to 30. MB is how much here? MB is equal to 60. Hope you are getting, right? You are going to get 0.5. Now I'll substitute the value here. GA, look at here. It is Na is equal to how much? Na is equal to 47. 47 plus 0.5. So 47 upon 47.05. Children, if you simplify this, you are going to get 0.989. So GA is equal to 0.989. Now what I do? I substitute the value here. And look at here. PA is equal to PA naught, you know that. How much? PA naught is equal to 23.8. 23.8 into, look at here, GA, it is equal to 0.989. Is it not? If you simplify this, you're going to get 23.58 mm mercury. So this is what PA, that means partial pressure of water in the solution. Children, let me take up the last numerical of this unit solutions. When 2.56 grams of sulfur was dissolved in 100 grams of carbon disulfide, the freezing point is lowered by 0.383 Kelvin. Calculate the formula of sulfur. Sx, that means you need to find out how many atoms are associated in the case of each sulfur molecule. Okay, so for that I need to calculate what? I. If I find out I, I'll come to know that how many atoms are associated to form a molecule of sulfur. Let me solve solution. Given data. WB is given is equal to 2.56 grams. WA is given how much? 100 grams. And delta TF is given how much? It is equal to 0.383 Kelvin. Kf is given, that is equal to 3.83 Kelvin kg per mole. And MB is given. MB is nothing but atomic mass here, 32. Right? What are you supposed to find out? I. Look at here. Delta TF is equal to I into Kf into WB into 1000 upon MB into WA. I reshuffle. I is equal to, look at here, Kf into WB into 1000 delta TF into MB into WA. Delta TF is how much here? 0.383 into MB is equal to how much here? MB is equal to 32. WA is how much? 100 upon Kf is equal to 3.83. WB is equal to 2.56 into 1000. Children, if you simplify that, you are going to get 0.125. I is equal to 0.125. I can write like this also, 1 by 8. Is it not? Hence, 8 sulfur atoms undergoing association to form 8S. In other words, you can write as S8. So this is what the solution for numerical which is written on the board. So there ends the unit solutions.